Hello, CS112. Today I'll be going over a quick solution to Lab 9, which has to do with recursion. So for this one, I'm going to do what I usually do and go through a quick solution, but then I'm really going to step through and explain the solution because recursion is hard, especially for some of you whose this is the first time actually working with recursion. I will be stepping through it in Python Visualizer at the end of this video. So just to talk about the gist of this problem is you're going to be given a list and you want to find the sum of only the even numbers using recursion. So for example here, you would be fed a list like this and you need to recursively calculate the sum of 2 plus 4 plus 6 plus 8 plus 10, which gives you 30. I've already copy and pasted the examples down here along with their expected output. But this was right under the assumptions and guidelines, and it's kind of giving you a major hint on something you need to use for your recursive call. When looking at this, you might wonder, well, wow, that's a really specific guideline. Well, yeah, because you should use something like this. So what this slicing is doing, obviously, is, K is a list. This is slicing off the very first element. So you can continuously slice off the first elements of numbers to iterate through the list recursively. Now, in thinking about recursion and what you need to do, it doesn't always have to be like this in this format, but this is typically how it is. So you have a base case, and then you have your recursive case. And the reason I say it might not always be like this is because you can have multiple of each. So I'm just going to put a little parentheses, an S there. So since we have looked at the guidelines and assumptions, and we know that we want to iterate through our list by continuously making it smaller, so every single recursive iteration, if you want to look at it that way, we're going to be removing the very first element. So after the first iteration with this list, our list is going to look like this, then it's going to look like this, so on and so forth. So our base case is going to be once we have removed every element from this list and the length of numbers, which is our list, is equal to 0. That is when we are done working. We're just going to return 0 because we don't want to add anything to our sum. Now for our recursive cases, what are the smaller problems we have to do? Well, we want to check every element at that first index and check if it is even. If it is even, then we will add it to our sum. If it is not, we will not do anything and just still slice off the first. So I'm going to put an else here just to put both of these guys in here. So we want to check if numbers 0. Now, why am I checking if numbers 0? Because that is the location will constantly check every recursive iteration and also constantly remove every current iteration. So, and we all know how to find if a number is even or odd. You just modulate it by 2, and if that equals 0, it is even. So I'm going to say return some even numbers with numbers, which is our list, sliced off the first element. So I'm going to say 1 colon, and nothing after the colon implies you want to go to the max length of the list. I'm going to leave it like this for now, but I'm just going to say what the else block is. So this is if nums at that first element is not even. We're just going to return this right here. We're just going to return we still want to get to the next element. So if 1's not even, we're not going to do anything about it. We're just going to go to the next element. However, up here, if it is even, so once we've gotten to, let's say, 2, so if our list looks something like this, we're checking the very first place, it has gotten to 2, well, we want to return the next iteration. So we want to return this list, but we also want to keep track of that 2 in our sum. So how do we do that? Well, we can actually add 2 to our, our return statement here. So numbers plus numbers 0. This is going to add number 0 to the function call here. And what recursion does, as I will dive deeper into at the end of this video, it will keep adding to the call stack, remembering each of these additions to your return and / recursive function calls here. So I'm just going to save this file. I added an A there accidentally. I'm going to save this file, and then I'm going to open up a terminal because I forgot to do that. Okay, so now that we are here, I'm just going to run it real quick. As you can see, we get the expected output. But now let us look through this in Python Visualizer to see what is happening, because it can be very tricky to try to just understand this if you are new to recursion. So I'm going to copy only this test case down, just so we can step through one of these together. Where am I? Here we go. All right, so now I'm going to call this function here, visualize execution, and now we can step through it and see what's happening here. And we'll talk more about that call stack I was talking about. So obviously, Python's going to read the very first line of code, which is this function, and then it's going to go down. It's not going to enter this function until it is called. So it's going to go down here. It's going to read the function call to that function with that list. It's going to go back up here. It's going to check our base case. So is the length of numbers equal to 0? It is not. So it's going to check our recursive cases. So is 1, which is at our list 0, is 1 even? It is not. So it is just going to go to our else block, and it is going to return some even numbers with the first element sliced off. So now, as you can see, 1 was sliced off, and now we are just working right here. And this is the call stack I'm talking about. Every single call to numbers, including our original one, is going to be added to the stack. And once we hit our base return case, all of these will pop up and add together. So that is where this will come in. So we're just going to step through this a little quicker now. So in this case, 2 is even. So we're going to say some even numbers with a list sliced off plus the first element. So this is going to add this to our return. And it's going to keep slicing off, slicing off. Our call stack got a little too tall here, so I'm just going to make it a little bigger here. So now we're at our last thing is 10. Well, the length of numbers here is not 0. So it's going to add this to our sum because 10 is even. So it should go right there. So now it returns this. And now we're doing a def sum even numbers function call with an empty list. So now when we check if the length of numbers is 0, it will return 0. And this return statement will cause all of these stack frames to pop off, all remembering what we added to the previous one. So when I click next here, it's going to return 0. Now we can look at our function call here. As you can see, I said return 0 up here, and we have a return value of 0 associated with this function call. So I'm going to click next. So now the return value is 10, right? Because we added 10 to we added 10 to our recursive function call. This is where the number 0 comes in. So when 10 is at location 0, we added 10 to it. So when I click next, our return value is still 10. Nothing was added to it because 9 is odd. I'm going to click next, and when I click next, as you can see, 8 is at the 0th place here, so that 8 will be added on, numbers 0, to our 10. So now we're at 18. The 17 won't be added, the 6 will. The 5 won't be added, the 4 will. The 3 won't be added, the 2 will, and the 1 won't be added. So this is where this all comes in. So it's all going to be saved with every specific function call on the call stack. And then once the call stack is terminated, or you have just a plain vanilla return statement here, it will essentially undo this call stack, remembering all of these. So essentially it's going to take all of these and add it to whatever is returned by this function, whatever is returned by the previous. And some of them, only the even ones, so only in this if block, only the even ones will have you adding the number at index 0. That's what the difference is between these two. This is actually like, modifying the return value. If we went back 1, 2, 3, this has nothing to it because this is being active in here. 3 is odd, so you're not adding anything to it, which is why 28 just is not, well, if we go back one more, which is why 28 is not changed when we go to here. But then when we go to this iteration, it will enter this if block, and you have the plus numbers 0, and that will change it to 30. So that's kind of the difference here. I hope this will help you guys out some more, especially with the project 5, I think it is, or whatever the recursive project is. If you have any questions, do let us know.